Protvino town. Institute of High Energy Physics. This town grew up out of a small village in 1960s. Those were the times when they built the so-called scientific towns around Moscow, such as Dubna, Pushchino and Protvino. Quite different ones, each of them being based around an important research institute. In Protvino, it was the Institute of High Energy Physics. Nowadays, they call them science-tons. Vladimir Dmitrovsky, mayor of Protvino town. Not just every town has the right to be called science-ton. Protvino has this right due to the number of staff workers in the institute and also due to the potential of its scientific base.
Тем основным фондом, по тем возможностям, которыми располагает институт, что из себя представляет его научная база.
It is quite evident that the national scientific base of proton accelerators has enormous density in the town's funds. That is why it can be by right called science-ton. Though it founded several decades ago to assure the Soviet Union's breakthrough in the scientific field. Almost 40 years flew away as they were just one day. Most of the veterans still remember the autumn's day of 1967 when the governmental telegram arrived. It came with congratulations to the whole group of workers, engineers and scientists who managed to build, assemble and tune the biggest elementary particles accelerator in the world. 76 billion electron volts, the biggest achievement in high-energy physics, put this country to the world's top position. The telegram, signed by academics Keldysh, Slavsky and Petrosians, most eminent physicists of the time, also wished all the best in fulfillment of scientific duties at this largest and unique structure. Through all these 4 decades, academic Logunov was tightly linked to the Serpukhov Accelerator, the High Energy Physics Institute and the town itself. It wouldn't be an exaggeration to say that it was him who built it, the real core of the Protvino town. The 70 giga-electron-volts Serpukhov proton accelerator marked the beginning of a new era of high-energy physics and technical accelerators and became a great impulse to construction of the next generation of accelerators. This provided Soviet scientists with a unique experimental base for conducting macro-world physics research. Academic Anatoly Logunov, director of the State Scientific Center Institute of High Energy Physics. The goal is quite simple: study of micro-world. In the beginning, we were dealing with protons, neutrons, and electrons. Further, it were positrons.
Тогда был протон, там нейтрон, электрон, затем позитрон, ну, вроде бы мимезон затем появился, ну, в общем, немного. Ну, и казалось бы, в общем-то...
This was when we thought we could explain everything having these kind of blocks in the palms of our hands.
Элементарные, из которых построена вся природа. Но оказалось, это совсем не так.
Although it turned out to be quite different. Accelerators they built in the 40s, 50s, and 60s provided new elementary particles, numbering several hundreds.
Очень много, уже сотни. И когда уже несколько сотен стало, то так, в общем-то, подумали, что, наверное...
This was when we thought we were just wrong. We thought those were not elementary particles, that they surely had a complex structure. And it was in the early 60s that the quarks idea came up.
Поиск вот тех вот, из чего построены все элементарные частицы. Вот тогда появилась вот идея кварков, что вообще говоря, что, может быть, все частицы состоят...
It was a presumption that all elementary particles consisted of kind of animalcular particles of quarks with a non-integral or fractional charge. For instance, it might be equaling 1/3 part of electron's charge, or say 2/3.
А здесь дробный заряд, заряд 1/3 заряда электрона, 2/3 заряда электрона. Вот это сразу, по существу, эти проблемы, они приводили к тому, чтобы увидеть все это.
To be able to see it all, we had to build accelerators of higher energies, just like a telescope that we use to watch things at great distances. And here it's the opposite. You build an accelerator to see what's inside elementary particles.
Ускорителя. Только тогда, скажем, вы можете рассмотреть, что внутри.
And this is when you can sort of feel them from the inside. So the analysis of these particles made it possible for us to explain things passing in the whole universe.
Элементарные частицы. Поэтому первый вопрос, который всегда стоял, это поиск тех частиц элементарных, их должно быть, наверное, немного, которые бы дали возможность объяснить, ну, всю нашу Вселенную.
The heart of this National Center of Fundamental Research of the matter structure and the nature of new forms of energy is the accelerator. It helped in discovering new physical phenomena as Magnon effects, scale invariance, and cross-section. It was here that they proved the complexity of elementary particle structure, discovered over 20 new particles of unique properties, worked out methodological principles of physical experiments, investigated physical phenomena of charged particles, and accelerating technologies of world level. The VES experiment. This experiment is designed to investigate mesonic resonances with both ordinary and, so to say, strange quarks, as well as gluons. Quarks were called strange for being born in pairs. The VES, or weight unity, is one of most fast-working in the Institute. In just one accelerator's downthrow, it acquires more than 3 million of beamed particles, with up to 8,000 triggers being registered. The DAT cassette recording houses about 15 megabytes of data. The experiment is highly competitive in the area of mass mesonic resonances, its results being published as special charts every 2 years. RAMPEX experiment. RAMPEX, or Russian-American polarization experiment, designed for studying properties of elementary particles through dispersion of protons and pi mesons at a target, with its nucleuses being polarized perpendicular to the bunch's direction. The experiment's goal is measuring the diversity of formation of secondary particles during transformation of the spin's direction, where spin means a notion dating the beginning of the 20th century, the so-called period of revolution in physics and one of the infancy of quantum mechanics. Decades after, physicists came finally to the conclusion that, besides such things as mass and charge, elementary particles also possess such a purely quantum property as spin. But let us get back to the experiment. Formation of secondary particles depends on the internal structure of the parent particles, while changes in spin's orientation make possible studying their configuration within the elementary particle and the fundamental properties of the matter itself. The Bars experiment. The unique labeled neutrino unit was designed in the early 90s in the Institute of Nuclear Research, together with other Italian and German institutes, for accelerating protons up till 70 billion electron volts energies level. At this neutrino and liquid argon spectrometer called BARS. BARS is a cryogenic two-cylinder vessel weighing about 300 tons, one of the biggest liquid argon spectrometer in the world, suitable for high cosmic energy and atmospheric showers research. This is the elementary particle separation scheme to separate husk from the veil. The charged elementary particles coming out of the target in a thin bunch are being all labeled at their initial flying stage, with the first deflector deflecting all particles but K mesons. The second one is simultaneously working on them with their super high frequency field. The heavy, or as they call them, unwanted particles, stay behind the lightweight or the wanted particles. This way, the bunch of the majority of wanted particles returns to their diametrical dimensions and gets stuck into the flat end of the central absorber, where it dies, while the broader part of the bunch of wanted particles bypasses the absorber and gets into the experimental physical unit. And this is when the experiment starts.
Физика наука экспериментальная, но с другой стороны,
The fonts of the idea. Physics is an experimental science, but on the other hand, all this must have its reflection in theory, and afterwards it's theory that will have to presume things. Sometimes theoretical thought is unable to work things out. This is when you need experimental data, which gives theoreticians the opportunity to formulate and propose something.
Если они предложат разумное, то есть в природе реализуемое, то оказывается это тоже полезно.
There may be many theoretical presumptions, but our Lord has created the nature in quite a different way. And it is up to theoreticians to understand the difference. So physics, being an experimental science, also needs to be theoretically digested. The Institute's theoretical department is well known and respected here and abroad. Theory and theoreticians. The biggest and most reliable Oleg Dahl Russian language dictionary, which came out over 100 years ago, describes it as inference, conclusion of your own, although not always true. Today, theoreticians possess a whole spectrum of instruments of highest precision, making it possible to computer simulate most widely ranged physical phenomena, which by themselves prove academic Loganov's words about inseparable togetherness between theory and practice. This tunnel is located at a depth of 50 meters. The ring is 21 kilometers long. The model was made up with a 1:1 scale. The superconductive magnets inside the ring assure clashes between protons at most high energies. Theoretically, it might assure the biggest density of nuclear substance, one that would equal the density of the universe at the very first moment of its genesis. Alas, this would only be possible if the magnets did fill the whole tunnel, but it requires neither more nor less than $150 million. Physicists and chemists. The Institute of High Energy Physics has a laboratory which uses chemical methods. It is mainly oriented at high-frequency superconductivity in collider techniques, in particular at creating niobium-based superconducting resonators. These resonators were once used in space programs. Physicists say they need big accelerating fields in the resonance structure, which makes it shorter, while the output energy of the accelerator and particles maintains the same. This is what they did in the laboratory. Creation of complex and unique experimental accelerating units requires first-class manufacture, which the High Energies Physics Institute possesses. Its main task is providing equipment for experiments in the U-70 equipment and colliders of foreign make. The pilot production produces optical and fine mechanics instruments, as well as various types of detectors ordered by the Institute. Special attention should be paid to production of special fireproof wires insulation, a most serious problem nowadays for institutes, production units, atomic power stations, and accelerating centers in Russia, the Ukraine, and Armenia. Partnership. International cooperation has been always part of the High Energies Institute activities in Protvino. They conduct their experiments in Europe, the United States, the world-famous CERN Center in Switzerland, in Brookhaven, and in the Fermi Laboratory in the United States. More than 60 experiments are staged in CERN, but we begin our story with the Delphi experiment. This detector has three components which form the huge magnet that gathers particles born as a result of collision. The particles are accelerated, and after colliding they interact. As a result, theoretical physicists and investigators obtained kind of a model of fundamental forces and elementary particles in nature. Russian scientists participate in supplying here complex magnets and other electrophysical equipment, including calorimeters. They also take part in setting up 4 units for conducting the ATLAS, the ALICE and the LHC experiments.
I believe that the efforts to fortify the work on the 70GeV accelerator, 76GeV accelerator, and in fact the possibility to use the magnets which are sitting there to make the high energy machine would be an excellent progress for the future. It would take probably 2 or 3 years to finish the work, but it would be very valuable for the Russian physics.
And here's one more example of international cooperation. The Fermi Laboratory and the Protvino physicists discovered the so-called top quark, one of the latest yet discovered blocks of the universe.
You the famous story about the American high-energy physicist Robert Wilson, he was testifying before the Congress to get money, and the congressmen have asked him, what will high energy physics do for national defense? And he answered, it doesn't do anything, but it makes the country worth defending. So we can say that when you work with particles that live 1 trillionth of a billionth of a second, that means nothing. But actually, the technologies that are needed to detect such particles are most advanced electronic technologies in the world. Without the influence of high energy physics, nuclear physics today would be zero.
The Institute of High Energy Physics still lives a hard life indeed. We've never heard scientists complaining. They're leading the life they've been used to, conducting experiments, thinking about exquisite solutions, and hoping they sometime do tool up the long ago built ring, and that their children, grandsons, someone will become interested in physics more than in business, for there are so many things in life which are ephemeral, while science is eternal.
Если эта область у нас совсем исчезнет, помрет, ну тогда
Academic Anatoly Logunov.
не будем на переднем крае.
If this area of knowledge finally disappears, that will practically mean we'll no longer be in the forefront of the battle.
Откуда можно ждать совершенно новые, потрясающие
High-energy physics, or physics of elementary particles, is one of the very few scientific areas where you can always expect amazing results and discoveries.
Физики высоких энергий, то есть физики элементарных частиц.
Scientific consultant Yuri Ryabov, scientific secretary of the Institute of High Energies. Written by Ella Vlasova and Yelena Gorina. Directed by Ella Vlasova. Cameras Dmitry Shakhov. Film editing by Andrei Semyonov and Maxim Vlasov. Musical editor Vera Kundrutskova. Studio manager Alla Sukonkina.